Welcome all. In this video I'm going to tell about what is meant by remote sensing and why we are using remote sensing and what are the elements of remote sensing and what is meant by electromagnetic rays. We perceive the surrounding world through our 5 senses. Some senses require contact of our sensing organs with the object. However, we acquire much information about our surrounding through the senses of sight and hearing, which do not require close contact between the sensing organs and the external objects. In other words, we are using remote sensing in our day-to-day life. Okay, may think what does the remote sensing means? Remote means far away distance and sensing means believing or observing or acquiring information about an object. Here comes the definition. Remote sensing is the science and process of collecting data from objects and area subjected to investigation by a device which does not have any physical contact with them. Here device is a satellite sensor which sent the electromagnetic energy to the ground surface, and the electromagnetic energy reflected from an object, and the reflected energy contains the information about the object which is recorded by the satellite sensor. Why we are using remote sensing? Because it is consistent routine global measurement and it provides a big picture which is the overview of the earth objects. It provides information where there is no ground based measurement, and it gives advanced warning of catastrophic events, and it is visual appeal. What are the advantages of remote sensing? It covers large area and it is time efficient. It provides a multi-temporal data and it also provides multispectral data. The main advantages is it overcomes the inaccessibility. Actually, there are some advantages. It needs a ground verification data and needs an expert system to extract the data. To acquire information about an object, there are some elements which are used by the remote sensing. First one is the energy source. Here, energy source is the sun and the satellite. The satellite produces the electromagnetic energy which travels into the atmosphere and it strikes the earth object, and the earth objects reflects the energy which contains information about an object, and the satellite data records the energy and it transmits to the ground station. In the ground station they use some interpretation techniques and some analysis to extract the information about the object, and it is produced to the user. Based on their decision making, they will apply in different application. And the electromagnetic radiation. The electromagnetic radiation is the important one in remote sensing. In remote sensing, some parameters of the targets are measured without being in touch with it. To measure any parameters using remotely located sensor, some process which convey those parameters to the sensor is required. In remote sensing techniques, the electromagnetic radiations emitted or reflected by the targets are recorded at remotely located sensors, and these signals are analyzed to interpret the target characteristics. The characteristics of the signals recorded at the sensor depend on the characteristics of the source of radiation, energy, characteristics of the target, and the atmospheric interaction. This lecture gives details of the electromagnetic spectrum, details of the energy sources, and the radiation principles. First, the electromagnetic energy includes all energy moving in a harmonic sinusoidal wave pattern with a velocity equal to that of the light. A harmonic pattern means waves occurring at the frequent interval of time. The electromagnetic energy has both electric and magnetic components with isolate perpendicular to each other and also perpendicular to the direction of energy propagation. It can be detected only through its interaction with matter. The electromagnetic energy can be described in terms of its velocity, wavelength, and frequency. All electromagnetic energy travels at the speed of light, which is approximately equal to 3 into 10 to the power 8 meter per second. The wavelength lambda of the electromagnetic wave is the distance from any point on one wave to the same position on the next wave. The wavelengths commonly used in remote sensing are very small. It is normally expressed in micrometer. Frequency f is the number of waves passing a fixed point per unit time. It is expressed in hertz. The three attributes are related by C is equal to lambda V, which implies that the wavelength and frequency are inversely related to C. Longer the wavelength have smaller frequency compared with shorter wavelengths. Engineers use frequency attribute to indicate radio and radar regions. However, in remote sensing, electromagnetic waves are categorized in terms of their wavelength location in the electromagnetic spectrum. This is the electromagnetic spectrum. The another important theory about the electromagnetic radiation is the particle theory, which suggests that the electromagnetic radiation is composed of discrete units called photons or quanta. This is the electromagnetic spectrum. The distribution of continuum of radiant energy can be plotted as a function of wavelength and is known as the electromagnetic radiation spectrum. The electromagnetic spectrum is divided into regions or intervals of different wavelength, and such regions are denoted by different names. The different regions of the electromagnetic spectrum are indicated in this figure. The electromagnetic spectrum ranges from gamma rays with short wavelength to radio waves with high wavelength. The visible region occupies a very small region The visible region occupies the very small region in the range between 0.4 to 0.7. Approximately, the range of color blue is 0.4 to 0.5 and green is 0.5 to 0.6 and red is 0.6 to 0.7. The ultraviolet region adjoins the blue end and the infrared region adjoins the red end. The infrared region spanning between 0.7 to 300 micrometer, and it has 4 subintervals of special interest of remote sensing. First one is the near infrared and short wave infrared, mid wave infrared, long wave infrared and far infrared. The longer wavelength beyond these regions are referred in units ranging from 0.1 to 100 cm. The microwave region spreads across 0.1 to 100 cm, which includes all the intervals used by radar system. The radar system generate their own active radiation and direct it towards the targets of interest. Next, based on the particle theory, Sir Isaac Newton was the first person stated that the light had only wave-like characteristic, but also light was a stream of particles traveling in the straight line. Light interacts with the matter. The EMR is composed of many discrete units called photons or quantum. And then the energy sources and the radiation's principle. The primary source of energy that illuminates different features on the Earth's surface is the sun. Solar radiation arrives at the Earth at wavelengths determined by the photosphere temperature of the sun. Although the sun produces the electromagnetic radiation in a wide range of wavelength, the amount of energy it produces is not uniform across all wavelengths. Using the particle theory, the energy of a quantum is considered to be proportional to the frequency. The relationship can be represented as shown. Q is equal to h nu. H is the Planck's constant and nu is the frequency. Using the relationship between C, lambda and nu, the above equation can be written as Q is equal to h nu by lambda. The energy per unit quantum is thus inversely proportional to the wavelength. Shorter the wavelengths are associated with a higher energy compared to the longer wavelengths. For example, longer wavelength electromagnetic radiations like microwave radiation are associated with lower energy compared to the infrared regions and are difficult to sense in remote sensing. For operating with long wavelength radiations, the coverage area should be large enough to obtain a detectable signal. Other than the solar radiation, the energy and the terrestrial objects also are the sources of electromagnetic radiation. All matter at temperature above absolute zero emits electromagnetic radiations continuously. The amount of radiation from such object is a function of the temperature of the object as shown as m is equal to T power 4. It is the Stefan-Boltzmann law. M is the total radiant existence from the source and sigma is the Stefan-Boltzmann constant and T is the absolute temperature of the emitting material in Kelvin. Since the Earth's ambient temperature is about 300 Kelvin, It emits the electromagnetic radiations, which is maximum in the wavelength region of 9.7 micrometer. This is considered as thermal infrared radiation. This thermal infrared emission from the earth can be sensed using scanners and radiometers. According to the Stephen Boltzmann law, the radiant existence increases rapidly with the temperature. However, this law is applicable for objects that behave as a black body. What does mean by black body? A black body is a hypothetical ideal radiator. It absorbs and remits the entire energy incident upon it. Total energy emitted by a black body varies with temperature. The spectral distribution or spectral curve is the energy distribution over different wavelengths or different temperature. The area under the spectral curve for any temperature is equal to the total radiant existence at that temperature. In addition to the total energy, the spectral distributions also varies with the temperature. The Stephen Boltzmann law is graphically represented here. This figure represents the Stephen Boltzmann law. As the temperature increases, the area under the curve, and hence the total radiant existence increases. From this figure, it can be observed that the peak of the radiant existence varies with wavelength as the temperature increases. The peak shifts towards the left. This is explained by the Wien's displacement law. It states that the dominant wavelength at which the black body radiates, lambda m, is inversely proportional to the absolute temperature of the black body. Here, A is a constant which is equal to 2898 micrometer. The sun's temperature is around 6000 Kelvin. And from the figure, it can be observed that the visible part of the electromagnetic energy dominates in the radiance existence from the sun. Thank you.